Good evening, my friends. Tonight, we'll drift together into a question as old as starlight itself. A question whispered by philosophers, poets, and scientists alike. Where does the universe end? Is there a wall out there, at the very edge of space? Is there a place where the stars stop shining, and beyond it, nothingness waits? Or, does it just go on forever, carrying galaxies endlessly into the dark? In this calm journey, we will explore what science says, what history has imagined, and what our human hearts secretly long to know. And maybe, by the time our minds are ready to rest, we'll discover that the end of the universe is less about where space stops, and more about how far our wonder can reach. Imagine yourself standing on a vast desert plain, sand stretching endlessly in every direction. The more you walk, the more horizon you see. At some point, you might ask, where is the edge of this desert? And yet the horizon keeps retreating, always staying just as far ahead. The universe feels like that, limitless, unreachable, and yet calling to us with its mystery. Now, here is the problem we are going to solve tonight, or at least try to touch with gentle curiosity. Does the universe truly end somewhere? Is there a cosmic wall, a final frontier beyond which there is nothing? Or is it endless, infinite, stretching further than our minds can grasp? And if it does have an edge, what lies beyond it? Empty void? A mirror image of our universe? Another universe entirely? These questions are not just science, they are philosophy, poetry, and dreams blended into one. When we ask about the end of the universe, we are really asking two things. First, about the physical structure of reality, space finite or infinite? Second, about the limits of human knowledge. Can we ever even know? Because when we look up at the stars, we are not just seeing pinpricks of light. We are seeing into the past. We are seeing stories billions of years old, carried across unimaginable distances, traveling into our eyes tonight. Think of it. The light from some of those stars began its journey before there were human beings to witness it. Some of that light began traveling toward us before there was even an earth. And yet, here it arrives, whispering, "This is what the universe looked like long ago." So the question of where the universe ends is also tied to time itself. Because the farther we look, the farther back in time we see. At some point, we reach a wall, not because the universe ends, but because light has not had time to reach us. And so we wonder, is that wall the end of everything? Or just the end of our vision? For thousands of years, cultures across the earth tried to imagine this edge. The ancient Babylonians spoke of a dome, a great vault arching over the earth, with stars pinned like lanterns to its surface. The Greeks dreamed of crystalline spheres, each one carrying the planets in perfect harmony, with the fixed stars on the outermost sphere. In Norse mythology, the universe was imagined as a tree, its roots and branches extending into realms beyond human comprehension. And in the flat earth cosmologies of many early cultures, the universe ended at the edge of the great ocean that circled the world. Beyond that, monsters, gods, or nothing at all. It seems that across cultures, humans have always placed limits around the universe. Perhaps because limits give us comfort. Boundaries make things feel understandable. Infinity, on the other hand, is frightening. It stretches beyond our imagination. To imagine a universe without end is to imagine a road we can never finish walking, a story we can never stop reading, horizon we can never reach. And yet, maybe that's the beauty of it. Tonight, as we sit together in the calm of this moment, I want you to imagine yourself on the very edge of everything. Picture it, you are traveling through the galaxies, one after another. You pass through the Milky Way, past the Andromeda Galaxy, past clusters upon clusters of stars. Millions of light years stretch behind you, billions more ahead. You keep traveling, and then, at last, you see at the edge of the universe. What would it look like? A wall of darkness? A shimmering veil? A sudden drop into nothing? Or maybe, just maybe, it wouldn't look like anything at all, because there would be no end to find. Scientists, of course, look at this puzzle differently. They asked, is the universe finite but unbounded, like the surface of a sphere? If you travel far enough in one direction, Would you eventually loop back around, just as a traveler circling the globe returns to their starting point? Or is space infinite, stretching on and on forever, never repeating, never looping, never ending? Both possibilities are staggering. Consider infinity for a moment. An infinite universe would mean infinite galaxies, infinite stars, infinite possibilities. Somewhere out there, in the endless vastness, there might be another planet exactly like Earth, with people exactly like us, having this exact conversation, wondering the same questions. It's a dizzying thought, and one that both thrills and unsettles the imagination. But even if the universe is finite, it does not make the question any simpler. A finite universe might still have no edge. Imagine an ant crawling on the surface of a balloon. The ant may travel forever without encountering a wall. It may think the surface goes on without end. Yet it is finite, it just curves back upon itself. Could our universe be like that? Could what feels infinite actually be a kind of grand illusion created by curved space? This is the mystery we carry with us, the problem we lean into tonight, the question of limits in a limitless feeling. Cosmos. And the beauty of this question is that it refuses to be answered easily. It invites us to sit with wonder, to rest in the unknown, to accept that some mysteries are not problems to solve but horizons to dream toward. Because when we ask, where does the universe end? Perhaps what we are really asking is, does anything ever truly end? When we speak of the universe, it's easy to drift away into abstraction, into images of galaxies colliding and black holes swallowing light. But sometimes, before we can ask the grandest questions, we must pause, breathe, and consider where we ourselves truly stand within this immensity. Because our place in the vastness is not just about coordinates on a cosmic map, it is about perspective, humility, and wonder. Let us begin very close, closer than the stars, closer even than the moon. Imagine Earth itself, this fragile blue sphere floating in the dark. It spins gently, carrying forests and mountains, oceans and deserts, cities bustling with life, and small quiet homes where hearts are beating, dreams are blooming, and stories are unfolding. From where we sit, the Earth feels enormous. To drive across a country takes days. To fly across oceans takes hours that seem endless. We measure our lives in these distances, and they feel vast to us. But then, let us step back. Imagine yourself rising slowly above the ground, higher than skyscrapers, higher than airplanes, higher than even the space station orbiting above. From this view, continents shrink into shapes we only know from maps. Oceans merge into one another. Cloud systems curl like brushstrokes across the canvas of the world. The entire Earth, vast to us when standing on its surface, suddenly appears delicate, a jewel suspended in black. Already, perspective begins to change. Already, we see that our sense of vastness is relative. Now rise further. Leave Earth behind, drifting outward until you see not just the blue globe, but the other planets circling our star. Mercury, scorched by the sun. Venus, shrouded in clouds so thick they trap unbearable heat. Mars, with its silent deserts and frozen poles. The gas giants, Jupiter with its storms, Saturn with its rings, Uranus and Neptune, pale and distant. Together they orbit the sun, a family bound by gravity. And there is our star, our sun, glowing fiercely, feeding warmth and light into the system. At this scale, the Earth is just one of many, especially large, not especially dominant. Already, we feel small, a participant in a solar story larger than ourselves. But the solar system itself is not the universe. It is not even close. If we rise further, higher still, until the orbits of Neptune and Pluto vanish behind us, we find ourselves within a bubble of comets, icy fragments drifting in the outer reaches, the Oort cloud, a boundary of sorts to our solar neighborhood. And even this vast bubble, trillions of miles across, is still just a tiny speck when compared to the next level of scale. For beyond the Oort cloud lies the galaxy, our Milky Way. It is a grand spiral, elegant and immense, containing hundreds of billions of stars. Each star, like our sun, may host planets. Each planet may carry moons, atmospheres, perhaps even life. When we place ourselves within the galaxy, our solar system is not at the center. It is not even in a particularly special place. It rests on one of the spiral arms, far from the luminous galactic core, quietly circling over spans of time so long we cannot truly comprehend them. Our galaxy itself is breathtaking in size. If you could travel at the speed of light faster than anything we know, you would still need 100,000 years to cross from one side of the Milky Way to the other. And remember, this is just our galaxy, one of billions. Imagine standing on a shore, looking out across an endless ocean, and realizing that each wave crest you see is itself an entire galaxy. That is the scale of the cosmos. And so we ask again, where do we stand? What is our place in this unfathomable arrangement? Are we significant? Or are we, as some would say, I'm more than dust adrift on an infinite tide? Here we must pause, because perspective can feel overwhelming. On the one hand, our smallness is undeniable. The Earth itself is smaller than a grain of sand compared to the Milky Way. Humanity is but a flicker in cosmic time. Everything we know, all of history, all of art, all of love, all of pain has unfolded on a thin film of life spread across the surface of a single planet, orbiting a single star, one among billions. To face this truth is to feel humbled, even insignificant, and yet, there is another perspective. For though we are small, though we are fragile, we are the universe becoming aware of itself. Stars burn and die, galaxies drift and collide. Black holes swallow light, but they do not ponder, they do not wonder. Only here, on this small world, has matter arranged itself into something that can ask the question, where does the universe end? Only here, in our fragile human minds, has curiosity blossomed like a flower against the dark. Think of it, a species of tiny creatures, living on a planet that is itself a speck of dust, has managed to send machines to the edges of the solar system, to build telescopes that capture the birth of galaxies, to imagine mathematics that describe the fabric of reality. Small though we are, we carry within us the ability to reach across the vastness with thought, with imagination, with wonder. That is our place, not just as occupants of the universe, but as its storytellers, its questioners, its dreamers. It is here that perspective softens. For yes, we are small, but smallness does not equal insignificance. A drop of water may be tiny, but it can hold the reflection of the entire sky. In the same way, each of us, each small human life, holds within it the ability to reflect the immensity of the cosmos. As we drift further outward, let us consider the larger scale still. Our galaxy, the Milky Way, is not alone. It belongs to a cluster, a small gathering of galaxies bound by gravity. Our cluster is called the local group, and within it are dozens of galaxies, each with their own billions of stars. From there, the local group itself is part of something even grander, the Virgo supercluster, a sprawling collection of clusters stretching across hundreds of millions of light years, and beyond that, still more clusters, weaving together into filaments and webs, forming a structure so immense that we call it the cosmic web, the skeleton of the universe itself. And here we are, still asking where we belong. In one sense, the answer is clear. We belong to Earth, to our families, to our communities. But in another sense, we belong everywhere. We are star stuff, as Carl Sagan once said. The atoms in our bodies were forged in the hearts of long dead stars. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of it was once part of some ancient stellar furnace. To know this is to feel not separate from the cosmos, but inseparable from it. When you look up at the night sky, you are not gazing at something foreign, something alien. You are looking at your origin. You are looking at the ingredients that make you possible. You are part of that vastness, and it is part of you. So our place, my friends, is not at the center of the universe, nor at its edge, nor anywhere in between. Our place is within it, as participants, as expressions, as witnesses. And though the scale is overwhelming, though the distances are unimaginable, though the numbers exceed our comprehension, we are still here, still alive, still asking, still wondering. And perhaps that is enough. Long before telescopes, before satellites, before rockets could pierce the sky, human beings stood under the night heavens and asked the same question that we still ask tonight. Where does it all end? But without the mathematics, without the instruments, without the scientific method we now depend upon, our ancestors had to answer with the tools they did possess: imagination, myth, faith, and story. And from those tools came visions of the universe that shaped entire civilizations, visions of edges, walls, and cosmic boundaries. Imagine, for a moment, the world as seen by the earliest humans. No maps, no globes, no continents stitched together in the pages of atlases. Instead, the land was simply what the eyes could see: the mountains nearby, the rivers that nourished, the forests that sheltered. Beyond that horizon, mystery. And, when night fell, the mystery deepened. The heavens became a canvas, and on that canvas, every culture painted its own vision of where the universe might begin and where it might end. Some of the oldest records we have come from Mesopotamia, the cradle of civilization. To the Babylonians, the world was imagined as a flat disk of land, floating on a vast primordial ocean. Above this disk stretched a solid dome, the firmament, holding back the waters of chaos that lay beyond. The stars were thought to be lanterns fixed into this dome, carried along by unseen hands. The sun and moon passed across the vault each day and night, slipping through gates at the horizon to return again. To them, the edge of the universe was not infinite space, but a dome, a ceiling, a limit as clear as the roof of a house. Beyond it, only waters and chaos. The Egyptians, too, saw the cosmos as a bounded structure, ordered and maintained by divine forces. The sky was imagined as the goddess Nut, arched across the heavens, her body studded with stars, her feet on one horizon, and her fingertips on the other. Beneath her lay Jev, the god of the earth, and between them, the air god Shu held them apart. For the Egyptians, the universe ended at Nut's arched body, at the horizon where she bent to meet the ground. To sail too far in one direction was to approach the end of the world, where the heavens and earth touched, and beyond that, only the realm of the gods. Travel further into history, and you find the Greeks with their crystalline spheres. To thinkers like Pythagoras and later Aristotle, the earth set unmoving at the center of all things. Around it, concentric spheres rotated, each carrying the sun, the moon, the planets, and the fixed stars. These spheres were transparent, crystalline, perfect. The outermost sphere was the realm of the fixed stars, glittering jewels embedded into the heavens. Beyond that outer sphere, the Greeks called it the primum mobile, the prime mover, or in Aristotle's language, the realm of the unmoved mover, a divine principle that kept all motion in being. For them, the edge of the universe was both physical and spiritual, a border beyond which only the divine could dwell. In Norse mythology, the cosmos was imagined not as a dome, not as spheres, but as a tree. Yggdrasil, the world tree, whose branches and roots connected the 9 realms of existence. The universe ended not at a wall, but at the limits of these realms. Asgard, the land of the gods. Midgard, the realm of humans. Jotunheim, the land of giants, and so on. Beyond the tree's branches lay the great void, Ginnungagap, a yawning nothingness from which creation first emerged. Here, the universe was framed not by a scientific geometry, but by a living structure, a mythic order of roots and branches. Reaching into mystery, the ancient Hebrews carried yet another vision, one echoed in the early books of Genesis. For them, as for the Babylonians, the earth was covered by a dome, the firmament. Above the firmament were the waters above, below it the waters beneath, and the earth itself rested in between. The sun, moon, and stars were set into this dome, eating across it each day. The edge of the universe, then, was the edge of the dome itself, beyond which stretched waters that only God could command. Cross over to India, and you find cosmic oceans again, but imagined differently. Hindu cosmology often described the earth as supported by great elephants, which stood upon a cosmic turtle, which itself floated in the infinite sea. beyond the sea, beyond the cycles of creation and destruction, Brahman, the ultimate reality. Here, the edge of the universe was not a physical wall, but a cycle, a rhythm of existence turning eternally, where endings were simply beginnings in disguise. And then there were the Chinese traditions, rich with images of balance and harmony. Some schools described the heavens as a rounded dome, circling the flat square earth. Others imagined infinite layers of heavens, stacked one upon another, each governed by celestial beings. Still others suggested the cosmos was boundless, with no true end, reflecting the Taoist belief in the eternal flow of the Tao. But for the common people, the sky was often seen as a great canopy stretched over the earth, and to reach its edge was to reach the place where heaven and earth met. And no matter where you look in the ancient world, you find that the idea of an edge was never absent. Whether it was a dome, a tree, an ocean, a wall, or a sphere, the universe was almost always bounded, limited, shaped into an order that could be imagined and described. To live without boundaries, without edges, was almost too much for the human mind to hold. Infinity was not yet a comfort, it was chaos, disorder, the unknown. So ancient people drew maps, built myths, crafted stories to place the cosmos within walls that could be understood. But notice something remarkable. Even when they imagined boundaries, they always filled the beyond with mystery. For the Babylonians, beyond the dome were waters of chaos. For the Norse, beyond Yggdrasil was the void. For the Greeks, beyond the spheres was the divine unmoved mover. For the Hebrews, beyond the firmament were the waters only God could touch. It was never simply nothing. There was always something: chaos, divinity, void, or eternity. The human mind could not accept an edge that opened onto true emptiness. Something had to be there, waiting, even if it was unknowable. And this tells us something deeply human. It tells us that the question of the universe's edge has always been more than science. It has been a question about meaning. Where does everything stop? What lies beyond the horizon? Is there chaos or order? Is there emptiness or a God? Is there an end or only another beginning? These ancient cosmologies, though we now see them as myth, were not foolish. They were the best answers available at the time, built not only from imagination, but from careful observation of the skies. The Babylonians tracked the movements of planets with precision. The Greeks invented geometry and logic to explain the heavens. The Egyptians mapped the stars in ways that guided the building of pyramids. Their stories were born from reverence, from the same deep hunger for understanding that drives science today. And so, when we ask where the universe ends, we are not alone. We are part of a lineage stretching back thousands of years, a lineage of dreamers and seekers who stood under the same stars and asked the same question, though in different words. If there is one discovery that has reshaped our understanding of where the universe ends, or if it even ends at all, it is this: the universe is not still. It is not frozen in place, with stars fixed like decorations upon a dome. It is not static, solid, or unmoving. Instead, it is stretching, expanding, like a great fabric pulled in every direction. This idea, so natural to us now, was once almost unthinkable. But tonight, in our quiet journey together, let us drift into the story of how humanity came to realize that the cosmos itself is growing. Imagine yourself in the early 20th century. Astronomers peered into the night sky through telescopes perched on mountaintops, their lenses collecting faint light that had traveled across unimaginable distances. At that time, most scientists believed that our galaxy, the Milky Way, was the entire universe. Those fuzzy smudges of light we now call galaxies were thought to be small clouds of gas, floating within our own galactic system. The universe was thought to be finite, relatively small, and eternal, neither growing nor shrinking. But then, a quiet revolution began. An astronomer named Edwin Hubble, working at the Mount Wilson Observatory in California, turned his telescope toward those mysterious smudges of light. What he saw and measured would forever change our place in the cosmic story. Hubble studied a class of stars known as Cepheid variables. These stars pulse with regular brightness, brightening and dimming over precise intervals of time. By measuring these pulses, astronomers can calculate their true brightness. By comparing that true brightness with how bright they appear from Earth, one can calculate distance. When Hubble did this, he realized something astonishing. Those smudges of light were not small clouds inside our galaxy. They were entire galaxies themselves, island universes, each containing billions of stars, each unimaginably far away. The universe, it turned out, was far larger than anyone had guessed. But that was not the most shocking part. When Hubble measured the light from those galaxies, he noticed a peculiar effect. The light was stretched, shifted toward the red end of the spectrum. This redshift meant one thing: the galaxies were moving away from us, and the farther away they were, the faster they seemed to recede. It was as if space itself were stretching, carrying galaxies apart like raisins carried outward in rising dough. The universe was not static. It was expanding. This discovery was like a gentle earthquake in the mind. It overturned centuries of assumption. No longer could the universe be thought of as an eternal, unchanging stage upon which stars and planets played their roles. No, it was alive in some way, dynamic, evolving. And if it was expanding, then logically, at some point in the past, it must have been smaller, denser, hotter. This realization gave birth to what we now call the Big Bang Theory. The idea that the universe began as a single point, a singularity, and has been expanding ever since. But what does it mean to live in an expanding universe? Let us slow down and imagine it. Picture yourself sitting in a field, gazing up at the stars. To your eyes, the night sky looks still. The stars do not appear to move apart. The constellations hold their familiar patterns. Yet on scales too vast for us to see in a lifetime, the galaxies are slipping away from each other. Space itself is stretching, and with it, the very fabric of distance is changing. To grasp this, astronomers often give a simple analogy. Imagine a balloon with tiny dots drawn upon its surface. As the balloon inflates, each dot moves away from every other dot. There is no single center on the surface of the balloon, no privileged point from which expansion begins. The expansion is everywhere, evenly. This is how the universe behaves. From our vantage point, it looks as if all galaxies are retreating from us. But if you were standing in a galaxy billions of light years away, you would see the same thing: all galaxies moving away from you. Expansion is not about galaxies flying apart into empty space. It is space itself that is growing. And here lies the subtlety. If the universe is expanding, then asking where it ends becomes even more mysterious. Because as space expands, the edge, if there is one, keeps receding. The universe, in a way, is outrunning itself. There are regions so distant that the light they emit today will never reach us, because the space between us and them is expanding faster than light can travel. For us, those regions may as well be beyond the edge. They are unreachable, hidden, forever beyond our cosmic horizon. This leads to a haunting realization. The observable universe, the part we can see, is not the same as the entire universe. The observable universe is bounded by the distance light has traveled since the beginning, about 13.8 billion years ago. But because space has been expanding during that time, the radius of our observable bubble is much larger, about 46 billion light years. Beyond that horizon, there may be countless galaxies, perhaps infinite in number, but forever invisible to us. So when we ask where the universe ends, we must first ask, do we mean the observable universe or the universe itself? The expansion also raises another question. Will it continue forever? Or will it someday slow down, stop, and reverse, collapsing back upon itself in a big crunch? For much of the 20th century, this was debated fiercely. Some believed gravity, pulling all matter together, would eventually halt expansion. Others suspected expansion would continue eternally, with galaxies drifting further apart until all became dark and cold. Then, in the 1990s, another discovery deepened the mystery. The expansion is not slowing down, it is speeding up. Some unknown force, which we now call dark energy, is driving galaxies apart faster and faster. The universe is not only growing, it is accelerating in its growth. This changes everything about how we imagine the edge. If expansion continues endlessly, then regions of the universe will drift beyond our reach, one by one. Distant galaxies will fade from view as their light is stretched beyond detectability. Someday, far in the future, observers in our galaxy may see only a dark sky, empty of other galaxies, unaware of the grand cosmic web that once surrounded them. The universe will not end with a wall, but with an emptiness born of endless expansion. And yet, expansion itself carries a strange beauty, because it means that space is alive, that the universe has a history, that it is not a fixed stage, but an unfolding story. Every galaxy we see tonight is part of that story, moving with the flow of cosmic time. Every star in the sky carries, within its light, the signature of that expansion, a subtle stretching, a quiet reminder that nothing is still. When we stand under the night sky, we may feel as though we are looking at something static, a painting hung above us. But truly, we are watching an unfolding motion too grand for our eyes to see. The stars burn, the galaxies drift, the universe grows. And in this expansion lies both a question and a wonder. If everything is moving outward, then what lies beyond? Is there an edge to expansion? Or does it simply go on forever, into a horizon we will never touch? When we ask about the end of the universe, there is a truth we must face gently, like lifting a curtain in a quiet room. We cannot see all of it. Our eyes, our telescopes, our most powerful instruments are limited not by their design, but by something deeper, the laws of nature themselves. The universe is vast beyond imagination, perhaps infinite, but what we see is only a portion of it, a bubble of visibility wrapped around us. This is what scientists call the observable universe. To understand this idea, we must remember that light takes time to travel. When you turn on a lamp in a dark room, the light seems instant, but in truth, it moves at a speed, an incredibly fast speed, about 186,000 miles every second. Yet even at that breathtaking pace, when we deal with cosmic distances, light takes time to reach us. The sunlight warming your skin today left the sun about 8 minutes ago. The light of the nearest star beyond the sun, Proxima Centauri, began its journey more than 4 years ago. And when we look at the faint smudges of distant galaxies through our telescopes, we are not seeing them as they are now, but as they were millions, even billions of years in the past. This means that the farther we look, the further back in time we see. The night sky is not a snapshot of the present, it is a vast museum of history, each star a relic, each galaxy a frozen image of what once was. The observable universe, then, is shaped not only by space, but by time itself. It is a sphere centered on us, not because we are special, but because we are the observers. Every point in the universe would have its own observable bubble, and the size of our bubble is determined by how far light has been able to travel since the universe began. The universe is about 13.8 billion years old. At first glance, you might think the edge of the observable universe would be 13.8 billion light-years away, since light has had that long to travel. But the truth is more surprising. Because the universe has been expanding all this time, the most distant regions we can see today are not 13.8 billion light-years away, but closer to 46 billion light-years. The expansion of space has stretched the distances even as the light was on its way. And so, observable universe forms a sphere about 92 billion light-years across. Pause with that number for a moment. 92 billion light-years. Imagine the Earth as a grain of sand, the solar system as a marble, the galaxy as a coin, and the observable universe as a sphere larger than any city, larger than any country, larger than the entire Earth itself. This bubble contains hundreds of billions of galaxies, each with hundreds of billions of stars. And yet, this bubble is not the whole universe. It is only the part we can see. Beyond it, there may be more galaxies, more clusters, more structures weaving together into patterns we cannot touch with our instruments. To illustrate this, let us imagine standing on a shore at night. Before you stretches the ocean, dark and endless. You see the waves near you, perhaps the glimmer of the moon on the water, perhaps a boat or two in the distance. But beyond the horizon, the ocean continues, vast and unbroken. You cannot see it, but you know it is there. The observable universe is like that horizon. It marks not the end of the cosmos, but the end of our vision. Beyond it, the ocean of reality continues. But unlike the horizon on Earth, which you could reach if you kept walking, the cosmic horizon is unreachable. It is not simply far away, it is moving away faster than light itself. Because of the expansion of the universe, there are regions forever lost to us, their light stretched and swallowed by the growth of space. Even if we had infinite time, infinite patience, infinite technology, we could never cross that horizon. It is not a wall we might one day break through. It is the edge of what is knowable, the boundary of the universe as we can experience it. This makes the observable universe both humbling and haunting. Humbling, because it reminds us that what we see is not all that exists. Haunting, because it leaves us with the knowledge that most of the cosmos is forever hidden, out of reach, beyond the veil of time and space. The galaxies we do see, the ones captured by telescopes like Hubble or the James Webb Space Telescope, are only a small fraction of the whole. For every galaxy we observe, there may be countless more beyond our horizon, invisible, yet real. And here lies the strange poetry of the observable universe. It is not defined by where the universe ends, but by where our light begins. Every photon that reaches us has a journey measured not in miles, but in eons. Some of the light we catch in our telescopes began its voyage when the first humans were not yet born, when Earth itself was still young, when continents were unformed. Some of it left its galaxies billions of years before the sun was born, long before our planet circled in the dark. And the oldest light we can see, the cosmic microwave background, comes from nearly the beginning itself. A faint glow left from a time when the universe was only 380,000 years old. This glow, this ancient light, forms the true edge of our observable universe. Not an edge of matter, not a wall of stars, but a veil of light stretched thin by time. Beyond it, the universe was opaque, a glowing plasma where photons could not travel freely. To look past it is impossible with our eyes, though. Perhaps not with our mathematics. Beyond that horizon lies the deep mystery of the universe's birth. And so, our observable universe becomes not only a sphere of visibility, but a sphere of memory. Every star, every galaxy within it, is not simply an object in space, but a story in time. To look outward is to look backward. To see the edge is to glimpse the beginning. The beauty of this idea is that it connects us to the cosmos in a profound way. When you step outside at night and gaze upward, you are not just looking at stars, you are looking through layers of history, through the lives of galaxies, through the unfolding of the universe itself. The night sky is not simply above you, it is behind you, beneath you, around you, carrying the memory of billions of years. And though the observable universe is vast beyond measure, it is still finite, still bounded, still just a bubble floating in what may be an endless sea. When we speak of the observable universe, we must always remember that the word observable carries with it a shadow. It implies there is more that is unobservable. A horizon, by its nature, does not mark the end of the sea, but only the limit of our sight. Beyond it, the ocean stretches further, unseen, untouched by our gaze. The same is true for the universe. The cosmic horizon that surrounds us does not mark the boundary of existence. It is not the end of space. It is only the place beyond which light has not had enough time to reach us. And so the question lingers like a whisper in the night air. What lies beyond the horizon? To approach this question, we must let go of the instinct to imagine the universe as a map with edges, as if it were a continent outlined by coastlines. The horizon is not a wall but a veil, and beyond it, the universe continues in silence. Astronomers, with their mathematics and their telescopes, cannot point to a photograph of this unseen place. They can only infer, imagine, and reason. And their reasoning suggests something both beautiful and humbling, that beyond the horizon, the universe looks very much the same as it does here. This idea is called the cosmological principle, The assumption that on the largest scales, the universe is homogeneous and isotropic. Homogeneous means it is evenly spread, like flour sifted across a table. Isotropic means it looks the same in every direction no matter where you look. If this principle holds true, then the universe beyond our observable sphere is not strange or alien but familiar. More galaxies, more clusters, more filaments of matter weaving into the cosmic web, stretching without end. The unseen is not different, only hidden. And yet, this is only an assumption. It may be that the cosmos beyond our horizon is not like ours at all. Imagine if the fabric of space changes. If the laws of physics are not universal but regional, like dialects spoken by different parts of existence. Some scientists suggest that beyond our cosmic bubble, there could be regions where gravity behaves differently, where atoms are unstable, where light itself does not move at the same speed. If the universe is infinite, perhaps every possibility is realized somewhere out there. Perhaps there are places where stars burn in colors we cannot imagine, or where galaxies form in shapes unknown, or where there are no galaxies at all. Even more mysterious is the idea of cosmic inflation. This theory, born from attempts to explain why the universe looks so smooth and uniform, suggests that in the very earliest moments after the Big Bang, space itself expanded faster than the speed of light. Not a motion through space, but an expansion of space itself, stretching tiny fluctuations into the seeds of galaxies. If inflation happened once, it might still be happening in pockets beyond our horizon. Entire regions of space could still be ballooning outward, creating new universes, new realms, forever cut off from us. In this picture, what lies beyond our observable universe is not just more of the same, but a vast collection of other domains, each one possibly different in its laws and constants. This is what some call the multiverse. But even without inflation, the thought of infinity itself bends the mind. If the universe truly extends without end, then every direction you look is merely the beginning of a path that goes on forever. Beyond the 92 billion light-year bubble of our sight, there would be another 92 billion, and another beyond that, an endless stacking of regions we will never see. In such a cosmos, our observable universe is like a single page in a book that never stops being written. To imagine its entirety is impossible, and yet the human mind still tries, still reaches, still aches to know. Perhaps this is where philosophy meets physics. We are not only asking what lies beyond in a literal sense. We are also asking about the boundaries of human knowledge. There will always be a horizon, even if our technology advances, even if we learn to capture fainter and fainter light. The expansion of the universe ensures that some regions are forever beyond reach. And so, what lies beyond is not only a question of space, but a question of mystery itself. It is a reminder that there are things we cannot know, and perhaps will never know. Still, we can dream. Imagine standing on a planet orbiting a star at the farthest edge of our observable bubble. To the beings there, their horizon would look just as ours does. A sphere of galaxies receding into the distance, but their horizon would overlap with ours only partially. They would see regions of the cosmos forever hidden from us, and we would see regions hidden from them. If we could stitch together all those horizons, all those overlapping bubbles of observation, the picture of the universe would grow larger and larger. And yet even then, no matter how many vantage points we collected, there would always be a beyond. This thought brings with it a curious comfort. The horizon is not a flaw in our perception. It is the natural shape of existence. Just as the ocean is more beautiful for being endless, the universe is more wondrous because it stretches beyond sight. The mystery is not a problem to be solved, but a reminder of the immensity in which we dwell. Scientists often compare the universe beyond the horizon to a region behind a curtain. We cannot lift the curtain, but we can listen to the whispers that escape through it. The cosmic microwave background, that faint afterglow of the Big Bang, is one such whisper, telling us about the state of the early universe before galaxies formed. Patterns in that light, slight ripples and variations, give us hints about what lies beyond, about how space was curved, how matter was spread, how inflation may have stretched the fabric of reality. The curtain remains closed, but the vibrations in the air hint at what the hidden stage might look like, and then there is the human imagination, which refuses to stay confined. When we speak of what lies beyond, we are also speaking of ourselves, of our yearning to explore, to extend, to transcend boundaries. The horizon is a mirror of our own curiosity. It reminds us that no matter how much we learn, no matter how far we see, we will always wonder what is next. Just as the sailor standing at the shore wonders what lands lie beyond the sea, we, gazing into the night sky, wonder what lies beyond the cosmic horizon. And perhaps it is not knowledge alone that drives us, but a kind of quiet faith that the universe, no matter how vast, is still something we are a part of, still something that touches us, even from beyond the veil. When we gaze into the night sky and ask ourselves what lies beyond the stars, there is another question hidden within it, a question that feels heavier and quieter. It is not only about what is outside of the observable universe, but also about the ultimate fate of the universe itself. Will it continue forever, expanding without limit into a silent and infinite darkness? Or will it reach some final chapter, a moment where all of space and time come to an end? The human mind cannot help but look toward endings, for endings are the rhythm of our lives. Our days end, our lives end. Even stars and galaxies have lifespans. It is natural to wonder if the universe, too, carries within it the seed of its own conclusion. And yet, the universe may also resist endings, stretching on without closure, refusing to give us the neat boundaries our minds crave. The first and most familiar vision of the universe's fate is what scientists call the Big Freeze, sometimes called the heat death of the universe. Imagine the universe as a vast engine. In its earliest days, it burned with unimaginable heat, a furnace of creation where particles collided with furious energy, birthing stars and galaxies. Over billions of years, that heat has spread thinner, stretched by the expansion of space itself. Stars form, shine, and then die, pouring their energy into the cosmic sea. But the second law of thermodynamics whispers to us that energy, once dispersed, cannot be gathered again. Over time, the universe moves toward a state of maximum entropy, a state of perfect sameness, where no energy flows, where nothing stirs. In the Big Freeze, stars one by one will extinguish, galaxies will grow dark, and the cosmos will fade into an endless twilight, not with a bang, but with silence. Space will continue to expand, but it will be cold, empty, and still, but not all. Visions of the end are so gentle. There is another scenario, one where the universe does not fade, but collapses. This is the Big Crunch. Imagine if the force driving galaxies apart, the mysterious energy of expansion, were not eternal, but temporary. If gravity's pull is stronger than expansion in the long run, then all of creation might one day slow, stop, and begin to fall back inward. Galaxies that are now drifting apart would reverse course, racing toward one another. Stars and black holes would collide. The universe would shrink, compress, and heat again, until everything collapsed into a final singularity, an echo of the Big Bang in reverse. Some have even imagined that from such a collapse, a new Big Bang might emerge, birthing a new universe in an eternal cycle of creation and destruction. In this vision, the universe has no ultimate end, but instead pulses in infinite rhythm, breathing in and out across ages beyond counting. There is also the strange and unsettling possibility of the Big Rip. Here, the mysterious dark energy that drives cosmic expansion is not constant, but grows stronger with time. Right now, we observe galaxies drifting apart, but if dark energy increases, that gentle drift could become a violent tearing. First, galaxies would be pulled away from each other at unthinkable speeds. Then, solar systems would come undone, stars torn away from their planets. Eventually, even atoms themselves could be ripped apart, the very fabric of matter destroyed by the accelerating expansion of space. In the Big Rip, the universe does not freeze or collapse. It shreds itself, unraveling into nothingness as every structure, down to the smallest particle, is stretched beyond recognition. These cosmic fates freeze, crunch, rip feel like grand, almost mythic stories, but they are not inventions of poetry. They are possibilities written in the equations of physics, each depending on the balance of forces we do not yet fully understand. At the heart of these questions lies dark energy, that invisible influence causing the universe to expand faster and faster. If it remains constant, we lean toward the big freeze. If it weakens, perhaps gravity wins and we collapse in a crunch. If it strengthens, the rip waits ahead. The truth is that we do not yet know, and in that uncertainty lies both fear and wonder. Yet, not every theory of the universe's destiny involves an end at all. Some scientists believe that infinity is not only possible but likely. In this view, the universe simply goes on, expanding forever. There may be no final freeze in any meaningful sense, because even as stars die and galaxies fade, new quantum fluctuations could spark new creations. Perhaps black holes, instead of devouring everything into silence, might give birth to new regions of space-time. Perhaps the expansion of our cosmos is only one ripple in an infinite sea, where new universes constantly bubble into being. In this vision, endings are illusions. What seems to end in one place begins anew in another, endlessly, without closure. And there are even stranger whispers. Some physicists wonder whether the universe is not destined for death at all but transformation. Space-time itself may be unstable, balanced like a ball resting in a shallow hollow. If our universe exists in what scientists call a false vacuum, then someday, perhaps tomorrow, perhaps billions of years from now, could tunnel into a lower energy state. If that happens, a bubble of true vacuum would appear somewhere, expanding outward at the speed of light, rewriting the laws of physics as it went. Inside that bubble, atoms would not hold together. Chemistry, stars, life, all would dissolve. The universe would not end, but it would change into something unrecognizable, governed by different rules, beyond our imagination. These possibilities are overwhelming, but they share a common thread. They remind us that the universe is not a static backdrop, but a living process, evolving and shifting on scales so vast they seem eternal. Whether it fades into silence, collapses in fire, tears itself apart, or transforms into something wholly new, the cosmos is not a place that simply is. It is a story unfolding, with chapters we glimpse and chapters we can only dream of. And perhaps that is the greatest lesson of all, that the universe is not a fixed object, but a flowing river, and we, for a brief moment, are carried upon its current. There is something deeply human about searching for edges. It is not simply a scientific pursuit, though science gives us the tools to measure, calculate, and imagine. It is a quiet hunger written into the way our minds work. From childhood, we want to know where things begin and where they end. A child asks where the road finishes, where the sky stops, where the ocean goes. It is not curiosity alone, but a need for closure, a comfort in knowing that even the largest things are framed within boundaries. The universe, however, stretches that longing to its breaking point, for it is the one thing we cannot place inside a neat border. Throughout history, civilizations have drawn invisible lines around the cosmos, not out of arrogance, but out of longing. The ancient Greeks imagined crystal spheres surrounding Earth, each one carrying a planet, the sun, the stars. Beyond the last sphere, perhaps there was nothing, or perhaps there was a realm of the gods. The Norse spoke of Yggdrasil, the world tree, whose roots and branches gave order to creation. Ancient Chinese thinkers envisioned the heavens as a dome, protecting and enclosing the world below. In all these visions, the universe was finite, shaped, contained. And there was comfort in that containment. To know that there was an edge was to know that the mystery, though vast, was not without limit. As human knowledge grew, the boundaries expanded. When explorers found that the ocean did not end in a waterfall, they redrew the edges of their maps. When telescopes revealed countless stars, the boundary moved again, stretching outward into the vast night. Yet even as the borders shifted, the longing remained. Each time a limit dissolved, the human heart sought another, a place to say, here it stops, Here the unknown begins. It is not only science that carries this longing but art, religion, and philosophy, all weaving stories about the ultimate frame of reality. Part of this longing comes from the way we experience life itself. Our own existence is shaped by beginnings and endings. We are born into time, and time eventually carries us away. Every day has a sunrise and a sunset. Every story we tell has a first page and a final line. In this rhythm of starts and finishes, we find structure and meaning. If the universe refuses to end, if it stretches without boundaries, then it resists the very pattern our minds rely on. Infinity unsettles us, because it offers no closure. Where there is no final chapter, we cannot rest in certainty. This is why the idea of the universe's end, whether through a freeze, a crunch, or a rip, resonates so strongly. It brings the cosmic mystery into the rhythm of human life, giving it a beginning, a middle, and an end. But perhaps the longing for boundaries is not only about comfort, it is also about belonging. To know the edge of something is to know where we stand in relation to it. On Earth, we know the edges of continents, the coasts where land meets ocean. We know the boundaries of nations, drawn on maps. These limits tell us where we are, who we are, how far we have traveled, and how far we have yet to go. If the universe has no edge, then our place within it feels uncertain, as though we are floating in a sea without shores. Boundaries, even imagined ones, give us orientation. They let us anchor ourselves against the infinite. In a way, science itself is an expression of this longing. Every measurement, every theory, every telescope peering into the dark is an attempt to sketch the outlines of reality. When astronomers define the observable universe, they are not claiming to have found the ultimate edge, but they are offering a boundary we can hold onto. The farthest distance light has traveled to reach us. It is not the true end, but it is something, a horizon we can name, measure, imagine. Even if beyond that horizon lies more space, more galaxies, more mysteries, we can at least say, this is as far as we can see for now. The boundary comforts us, even if it is temporary. There is also a deeper paradox in this longing. While we seek boundaries, we are also drawn irresistibly to cross them. The horizon calls the sailor. The edge of the map tempts the explorer. The limits of knowledge inspire the scientist. To know there is an edge is to feel compelled to reach it, to touch it, to see what lies beyond. This restlessness drives us forward, into new discoveries, new questions. The longing for boundaries is never satisfied, because the moment we reach one, we are already reaching past it. Perhaps this is why the universe never seems to give us a final edge. It matches our own endless hunger with endless mystery. Some philosophers suggest that our minds themselves are not built to truly grasp infinity. We can say the word, right, the symbol, imagine the concept, but we cannot truly hold it. We live in a finite body on a finite planet, within a finite lifespan. Infinity slips through our grasp like water through open fingers. To speak of a universe without end is to step outside the scale of our own being, into something alien to human experience. And yet, even if we cannot hold infinity, we are haunted by it. It stirs both awe and unease. It humbles us and unsettles us. And so again, we return to our longing for edges. Because edges are things we can know. Religions and myths often answered this longing with finality. The world has a beginning, created by divine will. It has an end, when time itself will close. These stories gave structure to the cosmos, not because they were measurable, but because they soothed the human heart. They promised that the universe, like a story, has meaning written into it, and that no matter how vast it seemed, it was ultimately complete. Science, by contrast, leaves the question open. It suggests possibilities, but does not yet close the book. In this openness, we feel both the thrill of discovery and the ache of uncertainty. The human longing for boundaries, then, is not weakness. It is a reflection of our nature. We are creatures of limits, creatures of time. We carry inside us the rhythm of beginnings and endings, and so we search for that rhythm in the universe itself. When we ask where the universe ends, we are not only asking about space and matter, we are asking whether the cosmos reflects us, whether the grandest scale of reality shares the same patterns as our small, fleeting lives. Perhaps this is why the question of the universe's end is not one science alone can answer. It is as much about psychology as physics, as much about the human heart as the stars. Whether the universe ends in silence, fire, or not at all, we will always imagine its boundaries, because to imagine edges is to be human. And even if those edges dissolve the moment we approach them, the act of seeking them gives us meaning. It reminds us that the universe is not only out there, stretching into infinity, but also within us, shaping the way we dream, question, and wonder. And so, after wandering through ancient myths, modern science, cosmic horizons, and the restless longing of the human heart, we return to the question we began with. Where does the universe end? Science tells us there may be no end, only a horizon that drifts farther with each passing moment, carried outward by the expansion of space itself. History tells us that every generation has drawn its own edges, imagining walls, domes, or seas beyond which the unknown begins. Philosophy tells us that infinity may forever escape our grasp, no matter how wide we stretch our imaginations. And our own humanity tells us that we will always search for limits, because limits bring comfort, orientation, and a sense of belonging. Perhaps the truth lies not in choosing one answer, but in embracing the mystery itself. The universe may not give us edges, but it gives us something just as powerful: wonder. It invites us to look up at the night sky and realize that we are part of something without measure, without boundary, without end. And in that endlessness, we find both humility and peace. The universe may never stop. It may never fold into itself, nor collapse into silence. It may simply go on, forever, carrying galaxies outward like leaves floating on a river of space and time. But even if we never touch its final edge, the search for that edge changes us. It reminds us of our smallness, yes, but also of our capacity to dream, to imagine beyond what we can see, to ask questions that stretch beyond our lifespan, our planet, our very world. And so, my friends, as you drift towards sleep, let this thought rest gently with you. The universe does not need to end for us to feel at home within it. The infinite does not erase meaning, it deepens it. For as long as we wonder, as long as we search, as long as we lift our eyes to the stars and whisper, how far does it go? We are already part of the very mystery we seek to solve.